Hello everyone, my name is MD Najibullah. My student ID 2024190230. This is my second semester. I am from ECU Enmol lab. My supervisor, Professor Jihun Lee. So now I am going to talk about the MMIC theory education. This is the chapter 1 of our course. So let's deep into the presentation. So firstly, we will discuss about what is MMIC. So it is a microchips it is actually from a microchips family. So this is a specific microchips that is elaborated, namely monolithic microwave integrated circuit, that is referred to MMIC. It is a type of integrated circuits, and this is a special circuit that actually works at high frequency. That is called microwave frequency, and that microwave frequency um, range is from 300 megahertz to 300 gigahertz. And these MMIC both have active devices and also passive devices. So it is a special kind of semiconductor chip. So combinedly, MMIC means monolithic. Mm. That is actually built on a single piece of semiconductor material. But unlike hybrid materials circuit, it is have separate components. And this monolithic semiconductor material chips operates on uh, microwave frequency, and this is obviously an integrated circuit. So the it has some key features and advantages over other chips. So in the figure we can see the features. It have in the layout of MMIC. We can see that you have capacitor, also have resistor, and it also include inductor and as well as a field effect transistor, and have related circuits as well. So the main features of MMIC, um, we already discussed about the components. So now we are talking about the advantages. So the main advantages is that the size. So we know that the IC actually uh, built to minimize the size, and this MMIC actually very less size. So the size very compact and significantly smaller than traditional microwave other circuits. Compared to other circuit, MMIC circuit actually is smaller in size, and the production cost is also low because the size is compact, and this MMIC provides uh, the high performance compared to other microwave circuits because of its material component. Later we will discuss about this thing. And as a result it have very high performance uh, factors. For this reason the integrated design leads to better reliability and repeatability compared to other discrete components. And for these advantages and key features, um, the MMIC have uh, a large widely range of use in electronics industry, in the communication systems, radar systems, as well as satellite systems and other applications that require reliable and high performance microwave circuits. This kind of MMIC actually used widely. Along with advantages, MMIC also have some disadvantages. So if we want to mention some disadvantages of a monolithic microintegrated circuits, so it can be listed as below, uh, such like as the MMIC have higher transmission line losses. It also display lack of tuning capabilities. Um, Sometimes it also have potential for undesired RF coupling problem also, and not only that, uh, limited it has limited component values. Beside that, the MMIC require most costly equipment compared to other microwave chips. For this reason, difficulty is occurred for maintaining thermal issues because there have some transmission line losses. For this region, the MMIC faces the thermal issues. Sometimes it gets heating issues, particularly with power amplifiers. Um, during the power amplifier, this thermal issue actually occurs, and this can increase the complexity and finally the cost of thermal management system, because we need to fix this thermal management system. For this reason, the cost actually sometimes increase. So this is one of the main drawbacks of MMIC compared to uh, the advantages. So MMIC first discovered in 1975. The first old MMIC was just an amplifier, and this was established by Ray Pengley and James Turner, and they published a paper, namely monolithic broadband gallium arsenide FET amplifiers, sealed their fate as the inventors of the MMIC. So at the lab of Plessy Lab, their little single-stage amplifier provided a range of 5 decibel of gain at X band, just using 1 micron optically retained gates. That was in that time that was extraordinary invention, uh, as you can say, because they just used computer optimization to design their uh, circuit. And this circuit actually just included capacitors and inductors, but surprisingly, no DC blocking on the input or output, because this was the first ever developed MMIC and the first generation of its kind. So backside processing had not yet been worked out on that time. So the FET source was grounded externally on that particular time. So now we are going to talking about the comparison between the MMIC and hybrid MMIC, the conventional MMIC and the hybrid MMIC. If we are going to talking about the comparison between this primary and secondary MMIC, then first we are going to talking about the construction difference. Due to construction, MMIC have the single semiconductor die. On the other hand, hybrid MIC displays discrete components on substrate. And if we go to the size variation, then MMIC is smaller compared to the hybrid MMIC. On the other hand, due to the size, the MMIC less costly than the hybrid MMIC, and as well as the reproducibility of MMIC is higher than a hybrid MMIC. Uh, Similarly, but on the other hand, we can say the design flexibility of MMIC is lower because the size is compact. Um, size is compact and is smaller compared to hybrid MMIC. And due to this reason, MMIC actually provides better performance compared to the hybrid MMIC. So now we are going to talking about the major MMIC production companies around the world. In our tech giant companies, we have a lot of tech giant companies that actually produce um, produce a bunch of electronic the components and kept a vital role to advancement of the MMIC. So they are the following names of the companies. We can mention the Skyworks solution, a of US based company, as well as some German based company they have Infineon Technologies, and we can also see the contribution of United Kingdom companies, namely Radiosat, and uh, last but not the least, the US based company, a renowned company Microwave Technology Incorporation. So the materials of MMIC. The MMIC actually utilize a variety of materials uh, available in the art materials as well. In build of MMIC, the gallium arsenide widely used. Beside gallium arsenide, there is also have application of usage of silicon. Beside silicons, we also use indium phosphide as well as silicon carbide and gallium nitride for their microwave function and millimeter wave frequency. And these materials actually provide the required microwave functions and the millimeter wave frequency that is the primary requirement to build an MMIC. So these materials actually fit to build the MMIC chips. So early in our presentation, we actually talking about the MMIC devices. So in our MMIC devices, we can differentiate the devices in two categories. One is active device and another one is passive device. So when we are going to talk about the active device, we have a lot of devices, renowned devices. We have MESFET. MESFET is the metal semiconductor field effect transistor, as well as we have also HEMT and HBT. So what the HEMT and HBT, both types of transistor used in electronic circuits, but they operate differently and have distinct advantages and disadvantages. Um, the HBT actually refers to heterojunction bipolar transistors. And beside that, we also have some other active devices that can namely GaN diodes and pin diodes. On the other hand, we have passive devices, and that is resistor, capacitors, inductors, and transmission lines. And there have a lot of application of MMIC devices. So that is all for my first chapter knowledge. Thank you, everyone.